melting point determination. This video will address how we will use a Thiel tube to measure the melting point of a compound, of a solid. Many times a chemist synthesizes a compound, or you do a reaction and you produce a compound you're pretty sure you know the identity of. But how do we prove that? Determining the melting point experimentally and then comparing that experimental melting point to what is theoretically predicted gives us evidence that allows us to say we made what we think we made. So throughout this year, we'll often measure melting point as a way to confirm the identity of a compound. What we will do is follow the exact directions that either I've given or your instructor has given you, as far as, are you using a known compound and then determining the identity of an unknown? Are you determining the identity of multiple unknowns? Are you just working with unknown? All right. A Thiel tube, I know looks odd, but it is specifically designed to contain mineral oil. And this shape allows for a nice equal distribution of an increase in temperature to your compound so that we can accurately measure and precisely when it liquefies. So we will actually hold the sample in a capillary tube, a melting point capillary tube. Capillary tubes are just very narrow, thin-walled glass straws, if you will. Some capillary tubes are open at both ends, so it's truly like a straw. These, however, are closed at one end, so some heat has been applied to close this shut. You just need a very small amount of whatever compound you're testing. So if you get a weighing tray and then simply just pour in a very small amount, or whatever your teacher directs you to do, you need probably half of a match head size. And you can always get more, we know that. I think the best method to load your capillary tube is to scoop and tap, being sure that you try not to come into direct contact with the compound. We just want to load the capillary tube. And you just have to add enough so that your eye can see the solid. So for my old eyes, I need about 1/3 depth of compound. So what I'll do is simply scoop and then tap it in, and scoop and tap it in. Now, I want to remind you guys, you know, you're super, super strong, and we want to be really careful in handling these capillary tubes. We do not want to hold them so tight or tap them so hard so that the walls crush or this breaks, and then you could possibly cut yourself with the broken glass. So scoop and then just tap to make sure it's collecting at the bottom. Scoop and tap. Oh my gosh, and that's a good 1/2 centimeter. I can definitely see that. And it'll be magnified a bit when you lower it into the mineral oil. Now, we need to make sure that we're measuring the temperature of this. You can, of course, utilize a thermometer, and we want to make sure that we are placing the capillary tube sample around where the temperature will be measured. So that, of course, is near the bulb of your thermometer. Whenever we can, though, we're going to utilize our probeware, and we can, make the same kind of conclusion that the bottom is the best place to go ahead and place your sample. And we're going to lower this so that the sample will be centrally located where the arm meets the main body of the Thiel tube. The directions talked about applying your heat at this portion of your Thiel tube. We know as the mineral oil increases in temperature, it's going to expand as the majority of substances do at higher temperatures. So that increase in volume is going to lower its density, and so it'll begin to rise, but then it will cool down as it's distancing itself from the heat source and then begin to circulate. So by the time it reaches your sample, we'll have a nice, slow increase of temperature that we'll be able to see on the LabQuest reading or the LabPro screen or the attached calculator to the LabPro screen. So how do we keep the capillary tube to the probe? Well, we're going to use orthodontic rubber bands, which are just really small rubber bands. I bet if you search your bathroom, you'll find some in a nook and cranny from those braces. Now, most steel tubes are filled with mineral oil. Mineral oil is just great at distributing heat nice and slowly and nice and evenly around the sample, a little better than water in a water bath. So, but similar in idea. However, it degrades when placed into contact with an organic substance. So we want to make sure that the rubber band, which is organic, does not get lowered and come into contact with the mineral oil. So the rubber band, try to keep that at the top. Now, how will we stabilize this inside of here so it doesn't fall at the bottom? Well, I would suggest utilizing a thermometer clamp. And then you can just adjust this as need be. And I'm just going to increase the grasping ability. And it's up to you. You could just lower the probe into the kind of area. I wouldn't support it with the rubber band. Either support it with that, or we could actually hug the rubber portion of the probe, and that probably will be a little more stable. I'm just going to tighten that nice and snug. All right. Now, as I said, you want to center your sample where this intersection is. So, before we start to change the temperature, I'm going to go ahead and lower that, and just make sure that it is not touching the walls of the steel tube. And so, it looks like maybe I need to adjust this. It's just being a little cranky. We know that sometimes our lab equipment will just not cooperate as quickly as we'd like it. All right, now, I also need to make sure that my wiring won't come close to the temperature probe. And, you could utilize another secure object like your faucet to just keep the electrical wiring away from the Bunsen burner. Now, what I would suggest is that, you're a team, so I would have one person definitely keep their eye on the sample. And then one person more your eye on the reading of the LabQuest or the LabPro. You are making note of when your solid first liquefies. Then the temperature at which you see complete liquid. Now we know pure compounds, unless they're an amorphous solid, they have a definite melting point. Even though this does a really good job distributing heat, it's not perfect. So we're not gonna get an instant, a specific temperature where it all will be liquid. You're gonna start to see your solid look wet, and then it'll all be liquid. So you wanna make sure you're taking your time with your increase in temperature. So you will definitely have to adjust your Bunsen burner flame so that your temperature is increasing no more than 1 degree Celsius every 60 seconds. So you may have to increase the distance that your field tube is from the flame. You may also have to just make your flame more gentle, or kind of just gently heat your mineral oil. Definitely ask me for assistance if needed. Okay, so you're gonna make a note of when you first see liquid and then when it's all liquid, and that will be reported as a range. So if you first start to see liquid at 26.4 degrees Celsius, and then it all is liquefied at 26.8, well then that will be the range that you report, 26.4 to 26.8 degrees Celsius. The midpoint of that will be what you use to identify it if it's an unknown. It would be wonderful if we could do a minimum of 2 trials, as long as the midpoint of both trials, the midpoint of both ranges, agrees within 1 degree Celsius. You can keep those 2 trials. If it doesn't, you need to do a third. All right, so between trials, do you have to get a new sample? No. All that you need to do is just raise this out of the oil, take away your heat, and allow the temperature to, well, you're gonna be taking the temperature of the air. So I'd give it a good couple of minutes. That will allow this, of course, to hopefully drop to a temperature below the temperature in the previous trial that you first started to see liquid. This, when it's exposed, of course, to the lower temperature of the air, will solidify for you. It is still the same pure compound from your previous trial. So you'll relower it, note the start of liquefaction and then the final, get the midpoint. Hopefully your 2 trials will agree. If you are collecting data from 2 trials, average the midpoints to determine the identity. There is a table of known solids that your unknown may be, and their theoretical melting points that you can use to identify what your compound is. Cleanup. Now, mineral oil, non-polar, so it's going to be a little finicky, and we can't just clean it up with water or just by wiping it down. Now, you probably just need to get a piece of, or we definitely need to get a piece of paper towel, and I will have a bin of soapy water already ready for us because I know that we're going to have to clean up. Wherever you set your cork may get some mineral oil places. So if you want to get a small beaker of the soapy water that I have available, of course, make your own, but I'll have it all ready for us. You can go ahead and just extract off the capillary tube and the rubber band. We will not reuse those. So if you want to use the paper towel to take that off and then dispose of this, but we need to clean this. So then, get more of the soapy water and clean this off. Make sure you rinse it with water before placing it away. Anywhere else you may have gotten mineral oil, make sure you're cleaning it up with soapy water. Now, depending upon your compound, you may have to really increase the temperature. We shouldn't put the cork back on until this is cool enough to touch. Now, please don't touch it to check if it's cool enough to touch. And put just your hand close and just listen to that inner voice that's saying, oh yeah, if you can touch it, or oh, don't. Do not worry. If you need me to place these away for you, I definitely will later. But once it's cooled down enough that's still maybe warm but safe for your skin, going to place that cap back on, undo this, and place it back in the container I use to hold these. That is the melting point determination lab. We will repeatedly use field tubes to measure the melting point of different substances that we create or produce throughout the year.